I introduced spontaneity to you, right? In the last class.
Yeah.
Okay. Because we discussed the entropy, and then we came to this equation. Remember this one, last one on this.
Yeah.
This, right? Delta S universe is delta S system minus delta H system upon T. That is how delta S surrounding was defined, right? It depends on the enthalpy change of the system and temperature. Right? So this is the final equation. Okay. Delta S universe is actually delta S system minus delta H of the system upon T. Okay. Then we made some changes to this equation. Okay, this is the slide. Now, for a spontaneous reaction, we want delta S universe to be positive. Okay?
Okay.
Now, if delta S universe has to be positive, then this has to be positive and this quantity has to be negative, right? Because then the entire equation will become positive, right? The entire quantity on the right hand side. So this is positive, and delta H of the system, because temperature is definitely positive, as 0 Kelvin is the lowest temperature possible, right? On a Kelvin scale we have always positive temperatures. Okay?
Yeah.
T is measured in Kelvin, so delta H of the system should be negative. So if delta H of the system is positive and delta H of the system is negative, then this air quantity becomes positive and the reaction will be spontaneous. Okay? Okay. Now what happens? Now rearranging the equation. This was the equation, right? Delta S system minus delta H system upon T, which is delta S of universe. If we rearrange, that is multiply the entire equation by T. Okay? This becomes, and after multiplying by T, we multiply it by a negative sign as well. Okay? So what happens? This is multiplied by T and minus 1, so this becomes minus T delta S system multiplied by T, so this quantity gets removed from here. This is multiplied by minus 1, so this becomes positive delta H system, and we have minus T delta S universe. Okay? Now this is the scientist who actually first realized that minus T delta S universe can be defined a new function. The condition is that there is no change in temperature. This is for one specific temperature, right?
Yeah.
The whole reaction is taking place at a constant temperature. So in that case, this whole quantity can be defined as Gibbs free energy change. It is named after this scientist only. Okay? This quantity minus T delta S universe. That is this one. Okay?
Okay.
We call it delta G. Noted by delta G. Now the free energy change delta G, it is a measure of the spontaneity of a process and of the useful energy available from such a process. That whatever energy or heat is actually utilized in doing the work is the useful energy available. Okay? Not all of it, but the useful ones. So this quantity actually measures the spontaneity of a process and the useful energy available for such a process. Okay? Next, so minus T delta S universe is delta G. It is defined that there is no change in temperature and no change in pressure. Okay?
Yeah.
Both these quantities are kept constant. Now delta G for a spontaneous reaction has to be negative. Defined. Delta G should be negative for a spontaneous reaction. That means delta S, that means this quantity delta S universe has to be positive. Delta G is 0 at equilibrium. That means delta S universe is equal to 0. And delta G positive, it is non-spontaneous. This is spontaneous in the forward direction. And this spontaneous in the forward direction, that is why it has written reverse is spontaneous. That means if you look at the reaction in the backward direction, for delta G positive, it becomes spontaneous in the backward direction. Instead of in the forward direction, it goes in the backward direction.
Okay.
So that delta S universe has to be negative. just opposite the sign. If delta G is negative, delta S universe is positive. Delta G positive, delta S universe negative. And for 0, both are zeros. Okay? Okay. Now standard free energy of formation. We read about enthalpy change. While reading about enthalpy changes, we know about combustion and formation, right?
Yeah.
Now, remember standard enthalpy of formation of elements which are already in the standard state was 0. Like delta H for oxygen or nitrogen molecules, they were all 0. Remember?
Yeah.
We were discussing. Similar, delta G for standard elements in the standard state is also 0. Okay.
Alright.
Okay. This is the equation for formation. This is the equation which we have from the last slide only. Delta G is actually delta H minus T delta S. And delta G in case of formation reaction, it is delta G naught F, which is equal to delta H naught F minus T delta S naught F. If the data is not in the formation process, then equation is slightly adjusted according to this. This is the general form, right? If the reaction is formation, we have F as a subscript, but this is general form, that delta G naught is equal to delta H minus T delta S. Now, like for entropy and enthalpy, we have, that is, for the entire reaction, we have another method of calculating delta G as well. For the entire reaction, it is summation moles into delta G of product minus summation number moles into delta G of reactant. Very similar to the last two. Right? Similarly for entropy and similarly for enthalpy we have, right? Summation of products into number of moles minus summation of reactants into number of moles, right?
Yeah.
One. Now this is an example. This is the equation. CH3OH plus oxygen giving you carbon dioxide plus water. Okay. Now what we have to determine is delta G of the reaction. Excuse me. See, what you've done is try to balance the reaction. Okay. This was reaction given. Now it is balanced. This is not balanced.
Okay.
Right? Because if you have 4H, this side you have only 2H, there's 3 O's and all. Okay, so now this is balanced. Okay. Then this is the data which is already provided to you. Delta H, delta S and delta G of all each individual components. Right? Like this is for H3OH, this is for O2, this is for CO2 and this is for H2O. What I have to find is delta H of the reaction. Now find delta H of the reaction, delta G of the reaction, sorry. It is delta H of the reaction minus T delta S of the reaction. Also, we can use summation of N into delta G of products minus summation N, where N is number of moles, into delta G of reactants. Okay. It means that either you try to find the delta H of the reaction. That means what you do is first you find the delta H for the entire reaction, right? With the given values. Okay.
Yeah.
And similarly delta S of the reaction with the given values. And put this equation, right? But you know the temperature in this case, right?
No.
Unless you know the temperature, you cannot use this equation. So what you do is you use these data to calculate the delta G. That is 2 times minus 394.4 plus 4 times minus 228.57 minus 2 times minus 161.9. And that is, if I have to write, then it will be 2 times minus 394.4 plus 4 times minus 228.57. This for the products, right?
Yep.
Yes. And
then times minus
yeah.
161.9.
Right. That will be for the reactants. This will give us the final answer. Right? 2 times minus 161.9. Okay, done. So this is the final delta G. Okay. But as you know temperature, you can use this reaction, this equation as well. But in that case, you will actually first have to find the delta H of the reaction, rest of the reaction with the available data, and put into this equation, and then you can finally calculate delta G.